Welcome to our educational channel. So in this video for class 10th ICSE Maths, the quadratic equations chapter. The entire chapter I'll explain in this video completely. So including examples, so each and every topic, let's discuss one by one. Okay, not only this chapter from this class, so all the other chapters from other class also. So including maths, physics, chemistry. So other information is available in this website. So link also is provided in description below just to go through this, right? So according to the required information, you can go through it. Now let us see this chapter first. So there are around 10 topics are there. So each and every topic briefly I'll explain. Now when you see the quadratic equations, so already which is studied in previous class, according to that. So in generally the general form, the quadratic equation form is ax square plus bx plus c is equals to 0. So equation is nothing but there should be equal symbol. Now is equal to 0. So A, B, C are, if you see this A, B, C are real numbers and A should not be equal to 0. Here A should not be equal to 0. For example, if it is A is 0, then x square into 0 is just completely 0. Only we have bx plus c. Now this is a linear equation. So quadratic equation means there should be highest power is 2. Right? So if you see examples, if you observe example like 2x square plus 3x plus 4 is equal to 0. So there are three terms, highest power is 2. Okay, the degree of this equation is 2. So when the power is highest power is 2, they are all quadratic equations. Now 2 should not, this is the number 2. If it is 0 means this entire term is not there. So 3x plus 4 is equal to 0. Now this is only linear equation. So it's not quadratic equation. So highest power is 2 is must. Okay, for example, only 3x square plus 4 is equal to 0. Yes. So this is also quadratic equation because highest power is 2. Now 4x square plus 3x is equal to 0. In this there is no constant term, but this also is a quadratic equation, right? That means any equation of the form ax square plus bx plus c, where a, b, c are the real numbers and a is not equal to 0. This is called a quadratic equation, right? Now let us see other examples in case if it is a fraction type. For example, let me write two examples here. X square minus 7x plus 12 is equal to 0. So this is a quadratic equation in terms of x. Okay. Instead of this, y square minus 7y plus 12 is equal to 0. This is also quadratic equation in terms of y. Right? Now let us see in fractions. For example, x plus 1 by x is equals to 2. So when we simplify it, we'll get the quadratic equation or not. So first, because highest power you can't see directly here. Here is highest power is 1, but it is denominator. So let us simplify this. So if you simplify, we'll get, okay, divide by 1. X is the LCM. X into x. X square plus 1 is equals to 2. So I did LCM now. X square plus 1 is equals to, take x right side, 2x. Now from this, x square minus 2x plus 1 is equal to 0. Okay. Now this is the general form, ax square plus bx plus c is equal to 0 and highest power is 2, a is not equal to 0 here. So this nothing is, this coefficient of x square is 1. X coefficient is minus 2 and constant is 1, right? That means this is also is a quadratic equation, right? Now these are the examples. Now let us see the roots of the quadratic equation. So let me continue same topic. Now for example, how we can find out the roots from this. So let me take the example and solve. A number, okay, for example t. Let us take ax square plus bx plus c is equal to 0. So in case in the place of x, let me keep alpha. Okay, if x is, that means if in the place of x, if we keep alpha, any number which I am taking some variable. Now let us take a alpha square plus b alpha plus c is equal to 0. In case if it is 0, then this is the root. Okay, let me take an example clear for you. For example, 2x square plus 3x plus 2 is equal to 0. Now in the place of x, what variable if I, what number if I'll keep, this entire becomes 0, then that is the root, right? Okay, for example, if x is equals to 1, that means 2 into 1 square plus 3 into 1 plus 2. Let us check it is 0 or not. 1 square is 1. Now it is 2 plus 3 plus 2. That is 5, 7. So this is not equal to 0. That means x is equal to 1 is the not root. So this is not the root. Let me take other example. Okay, if take when x is equals to 4 in, let me take a quadratic equation x square minus x minus 12 is equal to 0. Now in the place of x, I need to suppose to keep the 4. That means that is 4 square minus 4 minus 12 is equal to 0. 4 square is 16 minus 4 minus 12. Now this is, we need to get 0, not equal to 0. 14 minus 16 minus 4 is 12. 12 minus 12 is equal to 0. So we got the 0. So when x is equals to 4, this is satisfied to get the 0. Therefore, x is equal to 4 is the root of this equation, root of this quadratic equation. Okay, if x is equal to 2, if I keep, you will not get 0. So that is not the root. That means when we substitute the value in the quadratic equation, if we get equal to 0, that means LHS is 0 and RH is also 0, then it's the root. Otherwise, it's not the root. Okay. Just one more example. Let x is equals to 2. Just substituting x is equals to 2 in x square minus x minus 12 is equal to 0. Then how we get this substitute here? So from the place of x, we will substitute that value. That is 2 square minus 2 minus 12 is equal to 0. 4 minus 2 minus 12 is equal to 0. And 4 minus 2 is 2. 2 minus 12 is minus 10 is equal to 0. But minus 10 is not equal to 0. Right? That means LHS is not equals to RHS. Then therefore we can conclude that x is equals to 2 is not root of the equation. Right? So only the one thing, the value if is satisfied that given quadratic equation, that is the root. If it is not, that is not the root. Okay? Now how to find out the exact roots of the quadratic equation? Okay, the method of solving quadratic equation by factorization method, so by substitution method. So methods are there. Now let us see how to find out the quadratic equation, means the method of solving quadratic equation by factorization method. Now let us see the method of solving a quadratic equation by factorization. So how to use this factorization method to solve the quadratic equation? I'll take 5 different examples. So any type of question regarding one of the example you can see. So let me explain this factorization method. Let me take 5 different examples. So for example, first one. So 5 questions I'll take here. So if you take first x square minus x minus 12 is equal to 0. So now this is the quadratic equation because highest power is 2 and x square coefficient is 1 here. Okay, x coefficient is minus 1 because there is no number and constant is minus 12. Okay, let me take one more. Second one is x plus 1 by x is equals to 5 by 2. Okay. Now the first rule to before solving quadratic equation using factorization method, the first rule is we need to make the given equation free from the fractions and radicals and put it into the standard form. So if any question is in like fractions, so we should make into simplify and we should make into standard form. Okay, we know already the standard form of the quadratic equation. So that is ax square plus bx plus c is equals to 0. So any quadratic equation is given in any form, we need to convert into the standard form first. Now when you observe, the first question is already in standard form. but second is not. So second one we need to convert into standard form. So let us take the LCM by 1. There is no denominator. X square plus 1 by x. So we know already. Otherwise you can take cross multiplication. This first into x plus x square plus 1 into 1 is 1, divided by denominator is also multiplied in denominator place, is equals to 5 by 2. Now we can simplify this cross multiplication. 2 into x square plus 1. So 2x square plus 2 into 1 is 2. And this 5 into x is 5x. Now next step is we need to convert in order. That means x square term, x term and constant. So right side is x term is here. We should take left. That means 2x square plus 5 if you take left side minus 5x and plus 2 is equal to 0 because everything you take left, so 0 is left this side, right? Now this is the standard form and this is the standard form. Now let us see how to use the factorization method for this to solve it. First step is x square coefficient you observe 1 and constant is minus 12. X square coefficient and constant you multiply. That means 1 into minus 12. So if you multiply that both, 1 into minus 12 is minus 12 now. Now minus 12 we need to split into two parts. If you multiply, minus 12 should come. If you add, the middle coefficient is minus 1. If you add minus 1 you should get. If you multiply minus 12, if you add the minus 1, that means x square coefficient is 1 here. There is nothing means. So 1 into minus 12 is minus 12. When we multiply, same minus 12 you should get. For example, if you see 4 into 3, 4 3 is a plus 12, but we need minus 12. And 4 plus 3 are 4, 4 plus 3 is also not minus 1. So what you can take, you keep minus 4. Minus 4 into 3, minus 12. And minus 4 and 3, if you add, minus 1 will come. Right? Understood, right? If you multiply this both, you should get minus 12. If you add the same numbers, middle number. That means indirectly minus x I am converting into minus 4x plus 3x. Okay. So minus 4x plus 3x is minus x. And first term is x square, last term is minus 12 is as it is. Just only middle term splitting into two parts according to this convenient. Next step is we need to make two linear factors to 0. Okay, from first two terms, last two terms you can take common. That is, from first two terms if you take x common, x minus 4. Next two terms plus 3 common, x minus 4 is equal to 0. Right? From first two terms x is common, next two terms 3 is common. How we should take common means within the bracket you should get same again. If you take this step perfectly, automatically get the same in the brackets. Therefore x minus 4 is the overall common in this x is left, here is plus 3 is left. Now this is two linear equations we made into 0. Now according to the zero product rule, so we know zero product rule is this is also 0 or this is also 0. That means x minus 4 is equal to 0 or x plus 3 is equal to 0. This is a zero product rule. That means if a into b is 0, then a is equal to 0 or b is equal to 0. Right? According to that, x minus 4 is 0 means x is equals to 4 or x is equals to minus 3. So x is the 4 is one of the root and x is equal to minus 3 is one of the root. X is equal to 4. 4 if you substitute, you will get 0. In the place of x minus 3 if you substitute, you will get 0. Right? Now let me take other example. The second one already are taken, we convert into the standard form. Now this is the standard form. Now according to our method, so what is that? We should take x square coefficient is 2, constant is 2. Both you multiply, that is 4. Now if I multiply I should get 4, but if I add the same two numbers I should get minus 5. Right? If you observe 4 into 1 is 4 and 4 plus 1 is 5, but it is minus 5. So what you should take? You keep a minus 4 minus 1. Okay, minus 4 into minus 1 is plus 4. Right? We got it. And minus 4 minus 1 if you add, I'll get minus 5. So just we can split this. So minus 5x I can write minus 4x minus x and plus 2 is equal to 0 right side. This 2x square is as it is. I'm not changing. Now I count the converting into linear factors. Just to take first two terms, maximum common is 2x. So one more x is left. 2x into x is 2x squared. 2x common means other 2, because 2x into 2 is again minus 4x. You can verify also. Next to two terms there is no common, so just to take minus 1 itself common. Then x minus 2 is equal to 0. You can verify minus 1 into x is minus x, minus 1 into minus 2 is plus 2. Okay? This should be perfect when you do it. And within the bracket we got same x minus 2, x minus 2. Here is the 2x and there is 1. Now just take according to zero product rule, x minus 2 is equal to 0 or 2x minus 1 is equal to 0. Then from this x is equals to 2 is one of the root. And from this 2x is equal to plus 1, x is equals to 1 by 2. Okay, x is 2 and x is minus 1 by 2. Therefore your solution set. You must write solution set compulsory like this problems. So solution set is 2 comma 1 by 2. These two are the, because it's a quadratic equation, you get two solutions. This both. Let me show other different two examples more. Okay, let me I'll take 3, 4, 5 more, three examples I'll show. So one is 3x square plus 10x is equals to 25. X square is equal to 3x and x square is equals to 36. Okay, these two also quadratic equation, highest power is 2 and highest power is 2. First let me solve this third one. I'll explain this fourth and fifth questions. Okay, now according to the method, x square coefficient is 3, but this is not in general form, right? To convert the general form, 3x square plus 10x minus 25 is equal to 0. We should take into same, all should be left side. That is the first rule. Now x square coefficient is 3 and constant is minus 25. So when we multiply this both, so minus 75, we should make into two parts. So 10 should get, if you add 10 should come. If you multiply minus 75, so that is 15 and 5. So 15 5 is minus 75, but 15 plus 5 is not 10, not minus 75 also. So we take minus here. So 15 comma minus 5. 15 into minus 5 is minus 75. 15 minus 5 if you add, 10 will come. Okay. Now that is actually factorization concept. Now we can write this is 3x square plus 15x minus 5x minus 25 is equal to 0. So take 3x common from this, x plus 5. So minus 5 common, x plus 5 is equal to 0. So x plus 5 and 3x minus 5 is equal to 0. Now according to the zero product rule, x plus 5 is equal to 0 or 3x minus 5 is equal to 0. From this x is minus 5, one answer. 3x is equals to 5, so x is equals to 5 by 3. Second answer. So solution set is minus 5 comma 5 by 3. That's okay. Now let us see these two type of questions. X square is equal to 3x. So here there is no constant term. So whatever it is, just we can make into general form first. 3x take this side minus 3x. If there is no constant term, directly from these two only you can take the common. Okay. From these two, if you see, x take common, x minus 3, because in both x is there, is equal to 0. Same now, x is equal to 0 or x minus 3 is equal to 0. So x is equal to 0 is one of the solution. X is equal to plus 3 is also another solution. So solution set is 0 comma 3 for this. Now fifth example, there is no x term, but method is same. X square minus 36 is equal to 0. Take all the terms left side. If any one of the term is missed, either constant term or x term, then problem we can directly convert into easily. Means two linear equations. X square minus 36 we can write 6 square. Okay, just check it if it is possible, a square minus b square formula. It's possible. So x minus 6 into x plus 6. A square minus b square is a plus b into a minus b. So x is equal to 6 or x is equals to minus 6. Okay, because x minus 6 is 0 or x plus 6 is equal to 0. From those, these are the solution set. So according to this problem, the solution set is equal to 6 comma minus 6, right? Now these are the few examples just I show for using method of solving quadratic equation by factorization. So if you know the concept clearly, now I'll show some different examples. So not only this like simple, some more examples in some around 5 6 problems I'll explain. Then it's easily for you any type of problem will come in examination. Now let us see some problems in quadratic equations one by one. Now let us see the problems in solving quadratic equations one by one. So let me show different sums. So around 10 problems I'll show in different way. So how to solve the quadratic equation problems, and this we'll see this one by one. So let us see first. Solve 9x square minus 22x plus 8 is equal to 0 when x belongs to natural number and when x belongs to rational number. So n is natural and q is the rational numbers. First we need to solve normal quadratic equation method. So according to our method, now is it general form, right? 9x is ax square plus bx plus c. So that is 9x square minus 22x plus 8 is equal to 0. So this is the given quadratic equation. Now x square coefficient is 9 and constant is 8. So 9 into 8 if you multiply, that is 72. Now according to the method, if you multiply two numbers, 72 should come. Same numbers if I add, minus 22 we should get. Okay. Directly if you don't know which one, just normally like a factorization method you can solve. So 2 table 36 to 18. So while you are doing only you can solve once. So 2 into 2 is 4, 4 and 18. If you observe 18 plus 4 is like 22 you are getting. So while you are doing, you can by verifying the middle number you can check it. So 2 table has started. 2 into 2 is 4 now. 4 and 18. So no need of taking further. So you can stop this. So 18 into 4. That is 72. And 18 plus 4 is not plus 22. But you got minus 22. Just you can take minus 18 minus 4 in that case. Okay, like that you can take. Now this is 9x square. Minus 22x we will write. Minus 18x and minus 4x, right? If you add, minus 22, if you multiply, 72, then only we can take the product rule. That means you can make into two linear equations. From first to last two terms common. From first to two terms if you take common, so that is maximum 9 table, 9 and 18 and x also. So take 9x common, one more x and minus 2, because 9x into 2 is minus 18x. Same x minus 2 we need, so take minus 4 common. So sign is must. Some of you not keep your minus or plus. Sign is compulsory in the middle here. So minus 4 if I take common, then x minus 2 is from remaining two terms. Because same thing should come. Whatever in the bracket, same should be here. That is important. You remember. Now x minus 2 is common. Here is a 9x and minus 4 is equal to 0. Now this is the linear equations too. If you use the zero product rule, x minus 2 is equal to 0 or 9x minus 4 is equal to 0. Then from this x is equals to 2 or so 9x is equals to plus 4. From this x is equals to 4 divided by 9. So we got x is 2 or x is 4 by 9. Now according to the condition, first when x belongs to natural number and x belongs to rational numbers. So first one, that is when x belongs to natural number. From these two answers, 2 is belongs to natural number, right? And that 4 by 9 is does not belongs to natural number. So okay, according to the first question, solution set that is only 2, so not 4 by 9, right? And when q, okay, if you see the second one, so when x belongs to a rational number, so here as 2 is belongs to rational number, and 4 by 9 also belongs to rational number, right? All the natural numbers are rational numbers, we know that. So according to this, so solution set. So don't neglect 2 here. 2 is also rational number, that's important. So according to this, the solution set is equals to 2 comma 4 by 9. So only 2 is for natural number, but in rational numbers 2 comma 4 by 9 is the solution set. In this way you can, so if they'll give the conditions, after solving you can see these conditions and write the answer, right? Let me take one more example. If it is not only numbers, in terms of like a, b is given, also same concept. So let me show you. 3a square x square plus 11abx plus 6b square. Now x square coefficient is 3a square, right? So number is 3, and here is 6b square. So a square and b square is there, but 3 and 6, that is 18. Actually 18a square and 6b square, that is 18a square b square. So full x square coefficient and complete constant you just multiply 18a square b square. Now middle term, that is 11ab, except x, the coefficient of x is 11ab. Now this if you multiply, make into two terms, if you multiply 18a square b square should get, if you add 11ab should come. So first number you verify 18, right? So you can take this method. 18 means first 2 nines are 18. Check now, 2 and 9, if you add 8, 11 is coming, so no need to take further factorization again. So we can write this is 2 and 9. 2 into 9 is 18, but we need a square b square, so that is 2ab 9ab, okay? 2ab 9ab is 18a square b square, and 2ab plus 9ab is 11ab, right? We got it. So this we can write 2ab plus 9ab, and already 6b square is equal to 0, 3a square x square as it is. Now we can take the common from this both. So if you observe 3a square x square plus 2ab, so what you can take common? Only a. From this 9ab 6b square. Okay, if you try to take the common from this, so what is the maximum possibilities? So only a we can take common, and x also is right. So 2abx and 9abx, because 2ab plus 9ab is 11ab, but x also again, so 2abx plus 9abx. So according to that we can take ax common in this. Ax common means one more 3ax is left. Okay, only ax, so 1a 1x, that means 3ax. 2abx, ax common means 2b, right? From this 9abx plus 6b square, so only can take the 9 and 6, so 3 table, so 3b if I take one more 3 and ax plus this is 2b. Okay, just you can try to take the maximum common, within the bracket should get same. So finally we got 3ax plus 2b in bracket is same, common ax plus 3b, now is equal to 0. Now according to the zero product rule, that is 3ax plus 2b is equal to 0, or ax plus 3b is equal to 0. From this 3ax is equals to minus 2b, from this ax is equals to minus 3b. We need only x value, so except x minus 2b by 3a, here x is equals to minus 3b by a. Right? Now these are the two answers. So one is minus 2b by 3a, one is minus 3b by a. Therefore we can write the solution set. So solution set is equals to minus 2b by 3a comma minus 3b by a. So maybe either it's having variables or constants or numbers also. Concept is same. So don't forget the concept. And according to this, you can see the same. Now, not only this, let me explain some more problems in different some coming quadratic equation now. Now let us solve these type of problems. So when you have the square roots. So if you observe this question, root 3 x square plus 10x plus 7 root 3 is equal to 0. And one more question, this is not in general form. We'll convert into general form and it's solve. Let me show these sums now. First, before solving, we need to know one simple rule, that is root a into root a. Square root of a into square root of a is a. Because this we can write square root of a whole square, right? Square and root cancel, so that is you get a only. So root 2 into root 2 is 2, root 3 into root 3 is 3. Okay, remember that property. Now x square coefficient is root 3 and constant is 7 root 3. So if you multiply these both, so that is root 3 into 7 root 3. So root 3 into root 3 is 3. So 7 into 3 is 21. Now 21 we need to make into two parts. That two parts if you multiply 21, but if you add 10. So 21 if you take 3 table, because not in 2 table. So 3 sevens are 21 and 3 plus 7 is 10, right? It's simple. So 7 and 3. 7 into 3 is 21, 7 plus 3 is 21. 3 plus 7. Now according to that, if you write this step, root 3x square is as it is. In the place of 10x, that is 7x plus 3x we write. Plus 7 root 3 is equal to 0 as it is. Now from root 3x square plus 7x, so only x is the common. So here is root 3x plus 7. Now from 3x and 7 root 3. So here we can take 3, we can imagine root 3 into root 3. So 3 is nothing but root 3 into root 3. Just imagine. So 1 root 3 if I take common, see what will come over. So 3 is actually root 3 into root 3. So 1 root 3 if you take common, another root 3 is there, right? So we can write root 3x it is. You can check also, root 3 into root 3 is 3 and x plus 7, because root 3 is common, that is equal to 0. That's what this property you must know. Now it's problem is simple. Just take the root 3x plus 7 is equal to, okay, this is two terms, and one more is x plus root 3 is equal to 0. By using the zero product rule, so that is root 3x plus 7 is equal to 0 or x plus root 3 is equal to 0. Now from this both, root 3x is equals to minus 7, then x is equals to minus 7 by root 3, or here is x is equals to minus root 3 directly. X is minus root 3 and one more is x is minus 7 by root 3. So these are the both solution set. So therefore we can write the solution set. So solution set is, we'll get the two answers, because for every quadratic equation. So minus 7 by root 3 comma minus root 3. So you must write this last step compulsory in an examination point of view also, right? If it is clear, let me see another problem in this same part. So according to the quadratic equation, we need to convert into general form first. So before solving this, we need to write cross multiplication method. But if you do cross multiplication, that is x plus 2 into, okay, these both like this. First fraction numerator, second fraction denominator. That is 3x minus 7 is equal to as it is, and these both. That is x plus 3 to x minus 3. So and is equal to similar as it is. Left side and right side normal multiplication you do. So fact, like just take x and multiply this both in that way. So x into 3x. So 3x square and x into minus 7 is minus 7x. Again with 2 multiply these both terms. You already know this. 6x minus 14. And here also x into 2x is 2x square and x into minus 3 is minus 3x. Take first term and multiply both. Take second term, again multiply this both. So this is 6x minus 9. If you simplify more, 3x square minus x minus 14 is equals to 2x square plus 3x minus 9. Now take all the terms left side because we need to convert it to general form. So 3x square, that is minus 2x square, minus x plus 3x to this side, minus 3x, minus 14 already left side, this is a plus 9. So these three terms, when you take left side, change the sign, right? Now this is x square minus 4x and minus 5 is equal to 0. So finally we got x square minus 4x minus 5 is equal to 0. Now this is in general form, right? X square minus 4x minus 5 is equal to 0. Now minus 5. So minus 5, because constant of coefficient of x square is 1. So minus 5 you make in two parts. That is 4, 1 is a 4, but it's a 5 in it. So we can take 5 into 1, but minus 5 in it. So minus 5 into 1 is minus 5. Minus 5 plus 1 is minus 4. So this is minus 5x plus x. Minus 5 into plus 1x and minus 5 is equal to 0 as it is. If you continue, take x common, x minus 5 plus 1 common. Okay, there is no any common from last two terms. So take 1 as the common. Now x minus 5 into x plus 1 is equal to 0. So according to the zero product rule, x minus 5 is equal to 0 or x plus 1 is equal to 0. Then x is equal to plus 5 or x is equals to minus 1. Okay, from this both. So here is the solution set. Therefore, so solution set for this problem is 5 comma minus 1 or minus 1 comma 5, right? So whenever the problem is not in general form, just convert into general form first, ax square plus bx plus c. Then you can go for the factorization concept. Okay, not only these, some more different problems, because when you're, if you know the sum, you can pause the video and you can solve and check it. Otherwise you can continue. Now let me explain different problems in this quadratic equation how to solve. Now let us see some more examples. So when the question is like this, x by x plus 1 plus x plus 1 by x, just like reciprocal, and is equal to 34 by 15. So let us make this into general form, like ax square plus bx plus c is equal to 0, and let us solve. So next we will see another type of question also. Let me solve this first. So if you know already, you can try yourself, or you can see now. So we need to make into general form first. So whenever it is, you can take LCM. That means x into x plus these two and divide by denominators both. In that way you can multiply. So x into x, x square plus and these two. That means x plus 1 into x plus 1, x plus 1 whole square by both denominators also multiply in denominator place. That is x into x plus 1. That is equals to 34 by 15 is as it is. Okay, this is the first step. So whenever you have like this, if unable to do LCM, just do these two multiply and like this cross multiply and down you multiply and write in denominator place. So if you have need one more clarity, see once a by b plus c by d. So this value is AD plus BC by BD, right? So A into D plus B into C divided by B into D. So same concept I applied here. Now just will simplify this entire. So when you are simplifying, x square plus x plus 1 whole square, just you can apply the formula. x is a square plus b whole square. So a square plus b square plus 2ab. So x square plus 1 plus 2x divided by x into x plus 1. So that we can take x square plus x is equals to 34 by 15. We'll simplify left side again, then we can do cross multiplication. X square plus x square, that is 2x square plus 2x plus 1. Okay, write out in order. Into x square plus x is equals to 34 by 15. Now we can do next step, you just to do cross multiplication this sum. So just if you do cross, that is 15 into this entire. So that is 30x square, 15 into 2x square plus 15 into 2x, 30x plus 15 into 1 is 15. That I multiplied here. 34 into x square, 34x square minus plus 34x. Take all the terms left side. Then 30x square, these both also. So minus 34x square plus 30x is left side already, and this is minus 34x plus 15 is equal to 0. Now this is the minus 4x square minus 4x plus 15 is equal to 0. So make x squared term is always positive. Then it will be easy for you. So all the terms you can change. Just multiply it both sides. Whenever x squared term is negative, just change everything, all the sign. So minus 4x square is plus 4x square. This is plus 4x minus 15 is equal to 0. That means both side I multiplied with minus. So minus 0 is minus 0 only, it is no negative 0. So both sides if you multiply with minus sign, then it becomes like this. So make every time, this is important, every time make the x square coefficient is positive. In case if it is negative, just change all the signs, all the terms sign you just interchange. That's it. Now you can do normal factorization. That is 4 into minus 15 is minus 60. Right? Plus 4 we need if we add. So that is, if you observe, 6, 10 table, 10, 6 is 60, right? If you know you can go for like that, you can always factoration and check. I'll explain. Now we need negative 60, but this is a plus 4. So 10 minus 10 into minus 6 is minus 60. 10 minus 6 is plus 4. Now 4x square plus 10x minus 6x minus 15 is equal to 0. Take common. So 2x is the common and 2x plus 5. Okay, minus 3 common, 2x plus 5. Now 2x plus 5 is the common in both. Then 2x minus 3 is equal to 0. By applying a 0 product rule, just you'll get 2x plus 5 is equal to 0 or 2x minus 3 is equal to 0. Then x is equals to minus 5 by 2. So that I did here. 2x is minus 5, so x is minus 5 by 2 or x is equal to 3 by 2. So according to the solution set is minus 5 by 2 comma 3 by 2. You can write down. Let me show the next sum. Okay. If you observe this problem, if it's clear the previous one, you check once. If you see in the bracket, it is the same. So whenever you get the questions are like this: x by x plus 1 whole square minus 5 into x by x plus 1 plus 6. X square term, x term and constant, but within the bracket is same. So whenever you have like these sums, instead of taking different way, just to keep this x by x plus 1, take some other letter. So just by putting x by x plus 1 is equal to some y in the given equation. Then it becomes y square minus 5y plus 6 is equal to 0. As I said starting, this is a quadratic equation in terms of y, in terms of letter y. Now the method is same. Just you can split the middle term. So y square, 6 we have, that is minus 5 we need. 3 into 2, 3 into 2 is 6. But minus 5 we need. So minus 3 minus 2 you take. So minus 3y minus 2y plus 6. So you take y common, y minus 3 minus 2 common, y minus 3, right? Just in the bracket, y minus 3 and y minus 2 is equal to 0. So finally we got from this step y is equal to 3 or y is equal to 2. But our answer in terms of x actually. Now actually what you have taken, the y is x by x plus 1. Now next, wherever y is there, x by x plus 1 is substitute. Right? So x by x plus 1 is equals to y. That is 3 now. Or y value is x by x plus 1. That is equals to 2. If we simplify, then we get the values for differently. So x by x plus 1 is equal to 3. That is x is equal to 3 into x plus 1. Here x is equals to 2 into x plus 1. X is equal to 3x plus 3. That is x take one side, 3 take this side. So x minus 3x equal to 3. Minus 2x is 3. Then plus 2x is minus 3. Just change the sign. So x is equals to minus 3 by 2. X is minus 3 by 2 is one answer we got. Similarly here, x is equals to 2x plus 2. X minus 2x is plus 2. Minus x is equals to 2. That means x is equals to minus 2. You can shift the sign. Otherwise multiply the negative sign both sides, then x is equal to minus 2. Right? So therefore, the solutions that we can write. That is minus 3 by 2, comma minus 2. Right? So whenever the problem, instead of giving straight away, like these conditions, if you observe in the problem, convert into that value which is given some other letter, not y, t, any other variable you can take and solve, then you substitute. Okay. Not only this, so let me show you. So apart from this, let me show one more example. So like this question, one more example, and I have some also show from this factorization now. So let me show one more problem, same like previous. So whenever you get the question like this in quadratic equations, like 3 into 2x minus 1 whole square plus 4 into 2x minus 1 minus 4. So don't simplify this entire equation in general form directly. So just observe x squared term, x term and constant, right? Here 2x minus 1, 2x minus 1 is common. So if you expand this a minus b whole square and simplifying with 3, so you'll get the answer, but it takes a lot of time. And in examination point of view, we should go for easiest method. For that, whenever you get the values in the bracket, if it's same, just to substitute or some 2x minus 1 into other letter, other variable. So that means by substituting, that is 2x minus 1. So take some y. So in this equation, so if it is equation, in equation 1, then the question will be changed different way in terms of y. That is 3y square plus 4y minus 4 is equal to 0, right? So it will be changed. Now you can imagine this is the quadratic equation in terms of y, and we will solve first. Here is 3 and minus 4. Now this is general form. Now if you take 3, y square coefficient is 3 and constant is minus 4. If you multiply, that is minus 12. So minus 12 we need to make into two parts. If you multiply minus 12, if you add plus 4. So that is 6 into 2 we know. But we need negative 2, but here positive 4. So 6 into minus 2. 6 into minus 2 is minus 12, and 6 minus 2 is plus 4. So that is 3y square plus 6y minus 2y minus 4 is equal to 0. We can make like this. Now take the common. Take 3y common, y plus 2 minus 2 common, y plus 2. Same like quadratic equation how you factorizing. Same way you do as this. Now y plus 2 in bracket 3y minus 2 is equal to 0. So according to the zero product rule, y plus 2 is equal to 0 or 3y minus 2 is equal to 0. So from this y is equals to minus 2 or 3y is equals to plus 2. Once you get y value is 2x minus 1, right? The 2x minus 1 will substitute here. So this is also from this y is equals to 2 by 3. So actually y value is 2x minus 1. Now the 2x minus 1 will substitute in the place of y. 2x minus 1 in the place of y. So then it becomes minus 2. So 2x is equals to minus 2 and minus 1 take right side plus 1. 2x is equals to negative 1 because minus 2 plus 1 is minus 1 and x is equals to minus 1 divided by 2. We got for this. And here y is 2 by 3. So actually y is 2x minus 1 is equals to 2 by 3. Just to simplify this, 3 take left hand multiply. So 3 into 2x minus 1 is equals to 2. That is 6x minus 3 is equals to 2. So 6x is equal to 2 plus 3. 6x is equals to 5. From this x is equals to 5 divided by 6. Okay, we got two answers. One is minus 1 by 2 and 5 by 6. So therefore solution set you must write, because according to the ICSE pattern, solution set you must write once you solving the quadratic equation, that is minus 1 by 2 comma 5 by 6, right? This one. So the main important thing is whenever you see the problems in this category, okay, whenever this within the bracket, if you get the same like previous example, convert into some other variable and general form that you solve, then after getting the solution set for first two in terms of y, then substitute the value and simplify to get the value of x, right? This is the solving the sums in different examples. And not only this, when the equation in the form of in different forms, so apart from these examples, in other forms also there is some quadratic equations. So those problems also I'll explain now, you see. So in this quadratic equations, so some of the questions like in this form, okay, square root of ax plus b is equal to cx plus d. So this is the square root. So if any equation is in this form like ax plus b is equals to cx plus d. So if any question is like this format, how to solve the solutions and how to get the roots. Let me take one example and explain you. So for example, solve. So only in this type of format only we can do in the this method, right? For example, solve square root of 2x plus 7 is equals to x plus 2. Okay. Now under square root there should be positive value and square root of any value should be positive. That is important. So like these questions, whenever you get the problem, okay, so if you see here, so from this if you observe, ax plus b should be greater than or equal to 0. There is one condition. And cx plus d also is must be greater than or equal to 0. So our square root of the number we will not get negative, and under square root there should be negative. There should not be any negative numbers. So that means if any apart from these values, we can call some extraneous values that will be omitted. So first let us solve how to do, and after getting two answers, so to get the exact answers among them. So let us take. Now if any question is in this format, let us do the squaring on both sides. Okay, if we take this is equation 1. So squaring on, because we need to remove the square root. That's why squaring on both sides. So when you take the both the sides, so square root of 2x plus 7 whole square is equals to x plus 2 whole square. Here you can cancel square and square root. 2x plus 7 is equals to x plus 2 whole square formula. That is a plus b whole square formula. So x square plus 4, because 2 square is 4, plus 2ab, 2 into x into 2, so 4x. Take the terms one side, everything. So these two also are to other side. Then x square plus 4 plus 4x minus 2x minus 7. If interchange, change the sign. Okay, in general form, this is x square plus 2x plus 4 minus 7 is minus 3 is equals to 0. Right? Now this is the general form of quadratic equation. We'll get the two answers, but among the two, how to test, how to check exactly correct answer is important, this type of questions. Okay, now same like a factorization method if you apply. So minus 3 is a constant. So minus 3 we need. So you can plus 2 is 3 and 1. So 3 into minus 1. 3 into minus 1 is minus 3. 3 minus 1 is 2. Right? So then normal factorization you can apply. X square plus 3x minus x minus 3 is equal to 0. Then x common, x plus 3 minus 1 common, x plus 3 is equal to 0. Then we got x plus 3 into x minus 1 is equal to 0. By using a zero product rule, we'll get other values. Two values, x plus 3 is equal to 0 or x minus 1 is equal to 0. From this, x is equals to minus 3 or x is equals to 1. But these are the both answers, but among we need to verify is exactly which is correct in this, because some of the answers we need to extraneous values we need to remove. So test x is equal to minus 3 and x is equal to 1, both values will substitute in the question and will verify. Okay, let me do here. So checking, this is must, so when the problems are like this. Okay, the first one, when x is equals to, so we got two answers, right? One is minus 3 and one is 1. So first minus 3 will substitute in this equation 1. So that is square root of 2x plus 7. So 2 into minus 3 plus 7 is equals to minus 3 plus 2. So square root of 2 into minus 3 is minus 6 plus 7. 3 minus 2 is minus 1. Root 6 plus square root of minus 6 plus 7 is 1. That is minus 1. So square root of 1 is 1. Minus 1. So but 1 is not equals to minus 1. That means, so x is equal to minus 3 does not satisfy equation 1, so it's rejected. So x is equals to minus 3 is rejected. So these we can call them as extraneous values, so which we can remove, which values are rejected, right? Now next one, x is equals to 1. Let us substitute this now. Okay, and same, that is again putting x is equals to 1 in equation 1. So equation 1 is same, square root of, observe that this is 2x plus 7 is equal to x plus 2. 2x plus 7 is equal to x plus 2. Now let us substitute this x is equal to 1 in this. So square root of 2 into 1 plus 7 is equals to 1 plus 2. Square root of 2 plus 7 is equal to 3. Square root of 2 plus 7 is root 9, that is equal to 3. Root 9 is 3 in this. So 3 is equal to 3. Right? LHS is equal to RHS. So x is equals to 1 is satisfying equation 1. So that is satisfies equation 1. That means here is a solution set. So hence we got 2, but solution set is only 1 among these 2. So that is equals to only 1. Okay, not minus 3. Right? This is compulsory in this method, you should remember. So once you get the values, you don't stop the problem. So if any question in this order, so one side is square root and one side there is no square root. So by checking we need to confirm. So which is extraneous value that we should reject it, right? So this method you can follow. So whenever the equations of the form in this root ax plus b is equal to cx plus d type, right? And if another type of method, not only this, So another type of method also how to solve. I'll show one more problem now. Okay, so in this quadratic equations, let us see another format. If any question is in this form, like square root of ax square plus bx plus c is equals to dx plus e. Here a, b, c, d, e are the numbers. So let us take one example first and we'll do the problem. For example, solve square root of, only in this format only this method we should apply. Okay, so that is square root of 2x square minus 2x plus 21 is equals to, only LHS is the square root and RHS is 2x minus 3. Now we need to solve. So here is the important thing is under square root the value should be positive first. Okay, under square root is negative number, there is a complex, so it's not a rational numbers. Under square root the value should be always positive and this total answer also should be positive. Right? Based on this, now we need to satisfy the condition, that is ax square plus bx plus c must be greater than or equal to 0. Okay, apart from this any other answers they are the rejected, so that we can call this extraneous values, they will be rejected. Now let us solve this problem first. We'll get two answers and from those by satisfying this equation, which is a given equation, the question this one, which is not satisfied, that answer is not correct, right? First let us simplify. Now squaring on both sides because we need to remove the square root. So by squaring on both the sides from equation 1, so that is square root of 2x square minus 2x plus 21 is equals to 2x minus 3. Apply whole square on both the sides. This side, left side is square and square root cancelled. Then the remaining is 2x square minus 2x plus 21. A minus b whole square formula you can apply this right side. That is 4x square plus 9, a square plus b square minus 2ab. So 2 into 2, 4 and 4 3 0. So 12x. Now this one, take all the terms one side and simplify first. Right? Take all the terms other side. 4x square minus 2x square. Okay, plus 2x square to right side. And minus 12x, this is a plus 2x. Plus 9 minus 21 is equal to 0. Take all the terms only one side, then simplify. 4x square minus 2x square is the 2x square minus 12 plus 2, so minus 10x, right, and this minus 12, 9 minus 21. Okay, now this is the general form of quadratic equation. Now from this we can more simplify if we take 2 common, because 3 terms is divisible by 2. Now if you simplify, x square minus 5x minus 6 is equal to 0. 2 we took common and 0 by 2 is 0. So we can do in this way. Make the maximum any quadratic equation, make it to simplest form if is possible. Now minus 6 is a constant, middle term is minus 5. That will get 6 into 1. What will be minus 6, right? So minus 6 into plus 1. Now we can make into, we can find out the solution first. So x square minus 6x plus x, minus 6 is equal to 0. X common, x minus 6 plus 1 common, x minus 6 is equal to 0. Okay, x minus 6 is the common overall, x plus 1. By using the zero product tool, we'll find out the x values, that is x minus 6 is equal to 0 or x plus 1 is equal to 0, right? So x is equal to 6 or one of the solution, and x is equals to minus 1. Now these two are not exactly the root of the given equation. We need to check it out first, which is correct or which is wrong. So for that, let us do checking this both. Now when you are checking, this is must only when the problem is like this. So when x is equal to 6, So from equation 1 we need to substitute these all values. So which is the given question. Square root of 2x square minus 2x plus 21 is equals to 2x minus 3, right? This is the question. In this, when x, where x is the 6, that value substitute. Just by substituting 2 into 6 square minus 2 into 6 plus 21. This side is 2 into 6 minus 3. So square root of this is 2 into 36. 6 square is 36. Right? And minus 2 into 6 is 12 plus 21. And this side is 12 minus 3. Just both the sides you can see. Now, so square root of 36 into 2, this is 72 minus 12 plus 21, that is total 81. This side is 9, and that's it. So here the root 81 is 9. So 9 is equal to 9. So we got LHS is equal to RHS. Okay, LHS is equal to RHS we got. So therefore the x is equals to 6. This is the root of the given equation. Now not only this, let us check with minus 1 also. So when x is equals to minus 1, from equation 1 if you substitute square root of 2 into minus 1 square minus 2 into minus 1 plus 21. So that is equals to 2 into minus 1 minus 3. So square root of, you substitute this. So 2 into minus 1 square, that is plus 1, and 2 into 2 is 2, minus 2 into minus 1 is plus 2 plus 21 minus 2 minus 3. Right, this side is we got minus 5, but this side is 2 plus 2, 4 and 21, so 25. Square root of 25 is 5, but is equals to minus 5 got. But according to the what we got solution, this is different, but 5 is not equals to minus 5. So this is a extraneous root, so it is so when extraneous roots which is not satisfying, so we will be, it is rejected. So when it's rejected, only the solution set is only 6, right? So this is the not the solution, only x is equal to 6 is the solution set. We can write also. So compulsory it is, whenever the problems are in this type, after getting the solution, just to substitute in that, then you only can find out the answer clear. Right, now let us see after this, when the solution set is given, how to find out the quadratic equation. I'll explain now. When already answer solution is given, how to find out the quadratic equation from the roots. Let us find out now. So now I will find out the quadratic equation when the solution set is given. So generally till now, whenever the quadratic equations are given, we found using the method, we found the roots, right? So if they give the roots of the equation, then how to find out the quotient, how to find out the quadratic equation, let us find out. For example, find the quadratic equation when the solution set. So whenever the solution set is given, we need to find out. Okay, example. So for example, okay, solution set is given minus 3 comma 5. So minus 3 comma 5 solution set is given. We need to find out the quadratic equation. So for which quadratic equation, we'll get these two are the answers. So just to simple it is, we'll go the reverse process. So whenever the two answers, that means since the solution set is minus 3 comma 5, that means when you come to the solution, since so solution set is that is minus 3 comma 5, right? So then we can take one answer is x is equal to minus 3 or x is equals to 5. Okay, these are the both. Now when x is equals to minus 3, you can write x plus 3 is equal to 0, or x is equals to 5 means x minus 5 is equal to 0. So when x plus 3 is equal to 0 and x minus 5 is equal to 0, then x plus 3 into x minus 5 is equal to 0. So reverse of this 0 product rule. When these both are zeros and this product of them also 0 only. So okay, x plus 3 0 or x minus 5 0. Then x plus 3 into x minus 5 is also 0. Now just to do simplification this, we'll get the quadratic equation. Take x and multiply this both the terms. X into x minus 5 plus 3 into x minus 5 is equal to 0. Take the first term and multiply both. Take second term and multiply the complete second expression. X into x is x square minus 5 into x is minus 5x. With this 3 you multiply. 3 into x is 3x and 3 into minus 5 is minus 15 is equal to 0. Let us simplify this. X square minus 2x minus 15 is equal to 0. Right. Now this is a quadratic equation. Right? X square minus 2x minus 15 is equal to 0. For if you solve, you'll get minus 3 comma 5 is the solution set. Okay. I'll show one shortcut trick for this. So actually you can do in this way. So if you want to know the direct answer also, let me show one. So here is alpha comma beta are the roots. Here according to our problem, alpha is equals to, we have 2, right? So one is minus 3 and beta is equals to 5. So whenever alpha beta are the roots, then quadratic equation. So then the quadratic equation is x square minus alpha plus beta into x plus alpha into beta is equal to 0. So this is the quadratic equation when the roots are given. So alpha and beta are the roots of the quadratic equation. If you substitute here, so x square minus sum of the roots, that means alpha plus beta into x plus product of the roots alpha into beta. Just substitute these values where you get same x square minus 2x minus 15 is equal to 0 comma naught. X square minus alpha plus beta minus 3 plus 5 into x plus alpha into beta minus 3 into 5 is equal to 0. Simplify this. X square minus 3 plus 5 is 2. 2x minus 3 into plus 5 is minus 15 is equal to 0. Right? We got the same. X square minus 2x minus 15 is equal to 0. Same this also. So this is a shortcut trick. You can take it as whenever the roots are given, you can find out the direct quadratic equation. Otherwise, in normal process, you can do in this way also. So this is the method, and to get the answer directly right or wrong, just use this shortcut trick. Right? Whenever the two roots are given, general form of quadratic equation with the roots x square minus sum of the roots into x plus product of the roots. So alpha plus beta into x plus alpha into beta is equal to 0. Right? Now these are the problems when the quadratic equation solution set is given, and previously we found how to find out the factorization. Right? Now next, the problems which are not possible with factorization, we can solve those problems with the formula. So that is Sridharacharya's rule. So how to use the formula to find out the roots. So I will explain now and we'll continue that. So now whenever the quadratic equation is not possible with the factorization method, so we'll use the quadratic equation formula. So this is the Sridharacharya's rule. So let me show the formula and let us see how to prove also. So proofs are not required in ICSE note exam, ask an exam. But let me explain how the formula we can make. Okay, just at least you can remember the formula in this case. So for example, okay, if you write the statement, so this is only when we unable to do the quadratic equation solving by using factorization method. Then we can apply this formula. The roots of the equation. The roots of the equation. So we know that general form of quadratic equation is that is ax square plus bx plus c is equals to 0, and here a is not equal to 0. It's already discussed. So then whenever this equation, then x is equals to, because roots of the equation in the form of x, that is minus b plus or minus under root b square minus 4ac whole divided by 2a. So here a is the x square coefficient and b is the x coefficient and c is the constant. We will take the two roots because of the quadratic equation. We will get the two answers. Once you take plus, once you take minus. That's why plus or minus. Now this formula. So let us do the proof of this. So from the general form, how we can make this formula. So let me explain entire proof also once. Just only 3-4 steps. So if you see the proof, from the general form only we can do this. So already we know that, so ax square, general form is ax square plus bx plus c is equal to 0. From this we need to find out the x value, right? That should be equal to this. So let me show you. And take x terms one side and constant other side. Then that is ax square plus bx is equals to minus c. Right? Now x square should be alone. X square coefficient is a. Then divide throughout equation, divide by a. Now this is equation 1. Just if we divide with a, equation 1 divide by a, then that becomes x square, because ax square by a is x square, plus bx by a, that is b by ax, is equals to minus c by a. Enter equation 1, divide with a. And next, this we can convert into some a plus b whole square left side. So x square is there. So just for that, adding b by 2a whole square on both sides. On both the sides. Only these two you should remember. One is dividing with a, one is adding b by 2a whole square on both the sides. Then this will be changed, x square plus b by ax plus b by 2a whole square added left side. Similarly, minus c by a is already right side plus b by 2a whole square. So why I am taking means the left side you can convert, this is a plus b whole square formula. So a square and this if it is b square, middle is 2ab. 2 into x into b by 2a is b by a1. That's why you can convert, this is x plus b by 2a whole square. Now this exactly equals to a square plus 2ab plus b square formula. If apply, you get the same. Because finally we need to target is to get the x value. That's why we are doing in this way. And this side you can do LCM. If you simplify this entire, just you can make it minus c by a plus this is b square by 2a whole square, that is 4a square. Okay, then 4a square is LCM, a more 4a, so into 4 minus 4ac plus b square. So negative term take other side. Okay, this we can write b square minus 4ac by 4a square. Now this is our x plus b by 2a whole square. So if you remove this square, this side you can write the square root. That is x plus b by 2a square root of, the square you can take other side, becomes square root. Now only x value we need. So this is a plus or minus because square root you are taken. So x is equals to minus b by 2a plus b by 2a take other side, minus b by 2a plus or minus under root b square minus 4ac whole divide by, and 4a square also apply the square root, separate it. So square root of 4a square is becomes 2a. Next step, so x is equals to minus b by 2a plus or minus root b square minus 4ac by, this is also 2a. Now 2a is the both fractions, denominator is same, so therefore x is equals to minus b plus or minus root b square minus 4ac and whole divided by 2a. 2a is for entire denominator. So here is the condition is there, b square minus 4ac must be greater than or equal to 0 because under square root it should be positive value, right? So once you take plus and take minus, we'll get the two roots. So this is the this Sridharacharya's rule. We can apply whenever is the quadratic equations are not possible with factorization. Directly you can apply this formula and you can find out the roots, right? Now this formula, just remember, the main thing is you need to remember the formula at least. In case if you don't know the proof of also. In case you don't know the proof, just you can remember this formula first. Proving also is very simple, just only two steps. Now let me explain the some problems around 4 5 sums. I'll explain using this formula. Then you will get the problems in different way in exam also you can solve. Okay, now let me show you some solving a quadratic equation by using this formula. Okay, now let us see some of the problems which are done with using this formula. So quadratic equation formula. So here is the question is, solve the following quadratic equation and calculate the answer correct to two decimal places. So when I asked correct to two decimal places, we will not get the perfect square root. So we need to know some long division method also in this case. So let us solve this problem and let me show you some other problems also. Let us continue. So when you see this, here is the given quadratic equation is x square minus 5x minus 10 is equal to 0. Now this is in the form of general form ax square plus bx plus c, right? So this is in the form of ax square plus bx plus c is equal to 0. Then we can say that what is a. So a is equal to x square coefficient, that is 1, and b is equal to x coefficient is minus 5, and c is equals to constant, that is the 10. So we can take these all values. Now these values will apply in the formula, right? We know that if we call the formula by using formula x is equals to minus b plus or minus under root b square minus 4ac whole divided by 2a. Yes, so we'll apply in this and we'll find out the value first. Now let's take this values. So this will apply in this. So x is equals to minus b. Minus already it's a formula minus, and b value is minus 5. In that case, you keep the bracket and keep, because most of the students do mistake in this way. Minus b. So minus is in formula. B value is only minus 5. Plus or minus under root b square. So b is minus 5 square minus 4ac. A is 1 and c is minus 10. So maintain the brackets whenever you get the negative terms, you will not get mistake. And 2 into a is 1. Minus to minus plus, that is 5. So plus or minus 5 whole square. So it's a 25 because minus to minus plus. And minus 4 into 1 into minus 10. So minus to minus plus here. 4 ones are 4 and into 10 is 40. Divided by 2. So we got 5 plus or minus under root 40 plus 25 is 65. Divided by 10 or divided by 2. Now we should know root 65 value. So to get the root 65, you must know that long division method. So that is very important. So one sum I'll show here. So long division method concept also explained briefly in other videos, you can check. So anyhow, I'll show once again. 65 square root of 65 you need to find out. So after two decimal places, whenever they ask two decimal places, you keep 4 zeros. So keep a line like this, 2 to mark. So this long division method concept clearly in briefly I'll explain in previous class also, just to see that videos. Now 65, so which is near to perfect square is 64. Okay, so 8 8s are 64. Same we should get here and here. This left side and right side same. If it is near to 40 means 36 is perfect square. So, okay, this is near to 64. It's not more than 65. Before 65 only, which is perfect square, you see. 8 into 64 and balance is 1. Now this 8 should be double. That means 16. Now next set to take down 0 0. So next to place after 16 1. So 161 ones are 162 twos I should check. But 161 ones are less than 100 is less. So take one more set. When you take another set, you must keep 0 here and keep point, and you also keep 0. Because when you take the set after point, you keep the point. When you take additional set, you can keep 0. Now 160. So this place and this place should be filled to near to this 10,000. So 1601 ones are, 1602 twos are, 1603 threes are, check like that. So 1606 six are near to this 10,000. That is 9,636. Because 1607 sevens it more. Always remember this place and this place should be same. Okay, whatever it is remainder, because anyway it's more than 5. Now 8.06 you can take. Up to 2 decimal places you can stop this. So 5, we got 8.06. Now 5 plus or minus 8.06 divided by 2. So we have the two values. Therefore x is equals to. Then from this we will take x1's 5 plus 8.06 divided by 2, or x is equals to 5 minus 8.06 divided by 2. Let's take plus and let's take a minus. Now this is the 13.06 divided by 2, that is 6.53 to division, or x is equals to 5, this will become negative, so minus 3.06 divided by 2, that is minus 1.53. You can do division with this 2. So these are the both, therefore solution set. You must write solution set finally. So solution set in this problem is one is 6.53 comma, one is minus 0.5, minus 1.5. Okay. Now we must to apply the formula, then simplify, then only you have to go to the long division method. Okay. Not only this problem, more 2-3 sums are explained, then you can get some clear idea on this long division method also. Now let us continue with one more problem now. So same quadratic equation using the formula. So here is the problem is, instead of giving directly, they asked in this way. 5x into x plus 2 is equal to 3. So for this to solve, okay, just to take, first we'll simplify. So we need to convert this into general form. So according to the given, we'll simplify and convert into general form. So given is 5x into x plus 2 is equal to 3. This is 5x into x, 5x square plus 2 into 5x. So 10x. 3 take left side as minus 3 is equal to 0. Okay, right? Now this is in general form. That is, this is of the form, that is ax square plus bx plus c is equal to 0. Then where we can write the ABC values. So here is a is x square coefficient, that is 5, and b is the x coefficient, is 10, and c is equals to constant minus 3. So including the sign also write clearly, so which is positive, negative, everything, right? Now these values will substitute in the formula. So by quadratic formula we have that x is equals to minus b plus or minus under root b square minus 4ac all divided by 2a. In this formula we will substitute these values, so it is given. Now let us substitute one by one. If you take, therefore x is equals to minus b, minus is already formula minus, and b value is 10, okay, plus or minus under root b square, so 10 square minus 4ac, a is the 5 and c is minus 3, square root is only for that, and divide by 2a, so 2 into 5. We will simplify this now. Minus 10 plus or minus 10 square is the 100 plus it is because minus to minus plus minus of 4 into 5 into minus 3 and 4 5 is a 20 into 3 is a 60 here. Divide by 2 into 5 is 10. Now let us simplify this first, then only go for long division method. So when you simplify, minus 10 plus or minus, this is 160 divided by 10. Now this 160 near to 16 into 10 because 16 is a perfect square because root 16 is 4. So we can make this. So you can add this minus 10 plus or minus under root. You can take separately. So root 16 into root 10 divided by 10. Whenever it is possible, you can make it simplify. Then minus 10 plus or minus root 16 is 4. 4 root 10 by 10. So finally got minus 10 plus or minus 4 root 10 by 10 we got. That's it. Now root only for 10 it is, square root. Now if you find out square root of 10 value is enough. We can substitute because 10 is 10, 4, 10. These are all the normal numbers. Square root of 10 value you need to find out. Okay, that we go for long division method. So I will show here square root of 10. That means up to 2 decimal places. So after 10, we'll keep 4 zeros. If they ask 2 decimal places, 4 zeros you keep. Now let us see this. From right side, we take 2 mark and draw one line. Now according to this long division method, first set is 10. 10 is near to which perfect number? So 9 before 10. So 3 3 is a 9. Now 3 into 3, that is 9. If you subtract this, 1 we get. Now next set we should take down as it is. That means you can keep the point. Now whatever this 3, it should be double. That means 6. Now if you just remember next position after 6 and here same number should come. That means 61 ones are, 62 twos are, 63 threes are, which is near to 100. That is 61 ones only 61, right? Then if you subtract 39, now next set. That's why 2 I marked. You should take down. Now here units place should be double. So 61 is nothing but 60 plus 1. So this should be double. Extra 1. So 62. So whatever it is, this should be double. Only units place you make it as double and add to the tens place. That means this is a 62. Previous is units place is 3. So I make it double. Now 61 means 1 should be double. Not don't make double total 61. Only units place. Now 62. Now just to observe again the same process. These two places should be equal. So after 62, whatever the number same. That means 621 ones are, 622 twos are. Right? You have to check until you reach near to 3900. That's all this. 626 6 are. That is 3756. Same number. Now just leave everything. Whatever we got here, 3.16. Now this is the answer for us. 3.16. This so root 10 is equals to 3.16 up to 2 decimal places. Now this 3.16 you substitute in this. Therefore, x is equals to minus 10 plus or minus 4 into 3.16 divided by 10, or okay, once you take a plus, once you take minus, right? Now x is equals to minus 10 minus 4 into 3.16 divided by 10. You take separately like this. Then just to simplify, minus 10 4 into 3.16 12.64 divided by 10, or x is equals to say minus 10 minus 12.64 divided by 10. Simplify once you add and subtract this side. So minus 10 and this is a plus 2.64 divided by 10. That we know is 0.264, Up to 2 decimal places, okay, leave it. X is equals to 0.26, or x is equals to, same, this is minus 22.64, because both are negative numbers, you can add. And if you simplify this, minus 2.26. So 0.26 and minus 2.26. So this is the solution set. Okay, these two together you can write. So therefore, that is 0.26 comma minus 2.26. Because afterwards he got 4 here. So after 2 decimal places asked, third decimal place is less than 5. So you can stop that much. So this is the answer. So main thing is we need to substitute the values clearly. Once you get, so according to the long division method, so we need to take that value and we have to simplify. Right? So not only 10, let me show one more example also. So let me explain another example to get some more clearly idea to even to do long division method also. So let me show other example now. Now let us see other problem. So here is 2x square plus root 5x minus 5. So how to solve the quadratic equation by formula? This type of quadratic equation will solve now. So here is the given question. X coefficient, we have the square root number, right? So that is 2x square plus root 5x minus 5 is equal to 0. Now this is already in general form. So that is this is of the form. It is already general form, that is ax square plus bx plus c is equal to 0. So where we can write, then a is equals to 2 x square coefficient, and b is the root 5, and c is equals to minus 5. Now these values you just apply in the formula, right? Once you know ABC value, so by quadratic formula we have the x is equals to minus b plus or minus under root b square minus 4ac divided by 2a. Just remember this. Now when we apply the values in this, x is equals to minus b, b is the root 5 plus or minus under root b square, or b is root 5, for this square you apply, minus 4ac. So 4 into 2 into c is again minus 5 divided by 2a. So 2 into a value is 2. Okay, let us simplify this. Then x is equals to minus root 5 plus or minus root 5 whole square. So for this square and root cancel, 5 minus to minus plus, and 4 to is 8 and 18 to 5 is 40. So finally we divide by 4. So minus root 5 plus or minus root 45 divided by 4. Now root 45, instead of doing long division method for this both, let us simplify this problem in a simple way. If you observe, root 45 is in 9 table, right? 9 into 5, because 9 is a perfect square again. That's why you can make into parts. Plus or minus root 45, you can write root 9 into root 5. Square root of 9 into square root of 5 is square root of 45. Because next up, root 9 we can make it as a 3. So minus root 5 plus or minus 3 root 5 by 4. So then let x is equals to, take two options, minus root 5 once plus 3 root 5 by 4, or minus root 5 and minus 3 root 5 by 4. Now if you take this both separately, so minus root 5 is minus 1 root 5 plus 3 root 5. So this is a 2 root 5. So 2 root 5 divided by 4, one x value, or minus root 5 minus 3 root 5 is minus 4 root 5 divided by 4, another value, right? So these are the two values. We can cancel this 4 4. X is equals to minus root 5. Now finally root 5 value we need to find out. So this also cancel, right? 2 ones are 2 twos are. So root 5 divided by 2. So x is root 5 by 2 and x is minus root 5. So if you know root 5 value, we can substitute and simplify here, right? Let me take a long division method for root 5 now. We need to find out the root 5 value. So according to the method, just to take 5 point up to 2 decimal places. So you take the 4 sets and then take 2 from other side. 1, 2 sets, and here's only 1 because no more number. Now see the 5 which is near to the perfect square. Before 5 is a 4. That means that is 2 into 2. So 2 2s are 4. Same number you should keep there again. Subtraction is 1. When you take the next set 0 0, you can keep the point, and whatever the number here you should double. So now 2 becomes 4, right? Now the next place after 4 and here number should be same. That means 41 ones are, 42 twos are, 43 threes are. I have to check. 41 ones are 41, but 42 twos are 84, right? Because 43 threes are more than 100 will come, so don't take. Now if you subtract this, that is 16. Now take the next set 1600. So here 42, 4 as it is, this 2 should be double, is a 4. 44. Only units place must be double. Now this place and this place should be same. That is 441 ones are, 442 twos are, 443 threes are. Check like that until you reach 1600. So I solved 443 threes are. That is 1329. Because 444 fours are more than 600. So don't take that. That much you can stop. So this is a 2.23. Therefore root 5 value is 2.23. So this workout also should be beside the problem only, should in exam, not somewhere else. Then that is root 5 is, we got 2.23 divided by 2. So this is minus 2.23. So 2.23 divided by 2 is 1.115. Up to 2 decimal places 1.12, because third decimal is more than 5 and more, add the previous number, that number here. So therefore solution set 1.12 comma minus 2.23. Now this is the solution set. So anything just like this, any problems which are related to quadratic equation by solving formula, first to find out the ABC value and substitute in the formula. Okay, this is important. In the formula you substitute, then simplify, then you go for the long division method, right? That's very important. Now you can take any type of sums also, just only long division method concept is important, just and substituting and simplification is important. These are the problems. Now let us see the nature of the roots. So not only these problems, how the nature of the roots of the quadratic equation, and how the problems based on nature of roots of the quadratic equation. Let us see and solve the problems now. Now let us see how to find the nature of the roots of a quadratic equation. So any quadratic equation is given, without solving directly using the quadratic equation formula or without factorizing, we can say the nature of the roots. That means whether they are rational numbers or irrational numbers or real numbers or unequal, equal. So everything we can find out. So generally we know that the formula, general form of a quadratic equation is that is ax square plus bx plus c is equal to 0, right? And x value is minus b plus or minus under root b square minus 4ac divided by 2a. Now without solving this completely, just under root we have b square minus 4ac, so that we can that b square minus 4ac value we can take it as some d. So here d is the discriminant, so we can call it as a discriminant. So based on this d we can find out the nature of the roots. So this is a discriminant. Now based on this discriminant, so we can find out the nature of the roots. So there are the three cases. So maybe d is greater than 0 or less than 0 or exactly equal to 0. So based on these three cases, let us see one by one. So if you see the case 1, that is if d is greater than 0, that means b square minus 4ac value if it is greater than 0. So under root, if it is greater than 0, the positive value is all. So then roots are real numbers and distinct, right? Then the roots are real. So real numbers means under square root there should be only positive number like root 2, root 3, root 7, root 9, root 120, any positive number. So under root there should be positive number, that means greater than 0. Then roots are real and distinct. So your distinct means different answers. So once you take plus, once you take minus, right? So you'll get two different answers. So roots are real and distinct. So roots are real numbers as well as the two different answers. And in the same way, that means, for example, if you take the roots are alpha and beta, so then alpha is equals to minus b plus under root d by 2a. One is, and beta. Another root is minus b minus under root d. So d is the discriminant, that is b square minus 4ac. Just keep in mind that. Okay, in this first one, if it is greater than 0, roots are real and distinct. So real numbers as well as two different answers. And to see the case 1, in this also, if you see the case 1 and case 2, in first part only I am taking two cases here. Once observe clearly. For example, so anyway we know that d is greater than 0. So if d value is greater than 0 and the d is a not perfect square. For example, if it is not perfect square, that means if you get root 16 means we can write 4. If it is root 36 we can write 6. For example, if you get root 10, so that is not perfect square. So roots are unequal and irrational numbers. Every case is unequal. If it then roots are irrational. Irrational numbers, because we will get root 7. That is a irrational number. So root 9 means you can write 3 in this place. So in case d is greater than 0 and not perfect, then roots are irrational. At the same time, they are unequal. If same d is greater than 0 and if it is a perfect number, if it is a perfect square, then automatically roots are rational numbers. Roots are rational numbers will get. Okay, every example I will take some more examples and explain later. Let's see only the properties first. Right, this is the two cases. If it is d value is greater than 0 and it is not perfect means you get the irrational numbers. If it is again greater than 0 and if it is perfect square, roots are rational numbers. Rational numbers we know it. If it is a d value, if it is 49, then root 49 is 7, right? We can write in that way. Now these are the cases. And now second part, if you see. So second one, first one is d is greater than 0. If discriminant is exactly equals to 0, then if according to the problem, if it is d is greater than 0, observe once. So this b square minus 4ac is 0. So root 0 is 0. So entirely this is 0 completely. Only we have minus b divided by 2a, that's it, because it's completely 0. Only the minus b by 2a only get. So in case d is equal to 0, then roots are real. Real numbers, but each one equals to minus b by 2a, because there is no root b square minus 4ac, because there is entirely 0. Only one answer will get, that is minus b by 2a, right? And third case, if d is less than 0, means if we get under root negative numbers like root minus 2, root minus 3, so they are all imaginary numbers, then roots are unequal as well as they are imaginary, because under root there should not be any negative number. If it is negative number, they are imaginary numbers, imaginary and unequal. Two different answers will get, but the roots are imaginary. That means finally clearly we can conclude that we must have, there should be d greater than or equal to 0. Only this should be possible to get the solutions. Other than less than 0 means roots are imaginary. There is no root minus 3, root minus 2. So these are imaginary numbers. So we can't find the solution for those. So finally we can conclude that for all the real roots we must have d is the greater than or equal to 0. If it is greater than 0, two cases. If equal to 0, only one answer. Right? Now these are the nature of the roots in these three cases. Only based on this discriminant only we can see. Now how the problems will come, or the problems based on natural nature of the roots of the quadratic equation, how they'll ask. So just 4 5 problems I'll explain. Now let us see. So now when we see the problems based on the nature of the roots of the quadratic equation, so they'll ask the questions like this. Without solving the equation, so without solving using the formula, we need to find the value of p. The condition is roots are real and equal. So according to the method, when the roots are real and equal, so discriminant is equal to 0. So we should know that properties as we discussed previous. So here is the given equation. So given equation is px square minus 4x plus 3 is equal to 0. Now x square coefficient is a, x coefficient is b, and constant is c. So here according to the general form, so we know that ax square plus bx plus c is equal to 0 is general form. So from this, a is equals to p, b is equals to minus 4, and c is equal to 3. And roots are real and equal. So when roots are real and equal, the discriminant d is equal to 0. Okay, this is the rule. So actually d is the b square minus 4ac. That means b square minus 4ac value is 0. So when it is discriminated 0, so roots are real and equal. According to the condition, we should take this step. This is right. Now b square, just substitute these values. So here is the b is in the place of b, minus 4 whole square minus 4 into a is the p, and c is 3 is equal to 0. Just we'll simplify this. Minus 4 square is 16 minus 12p is equal to 0. We need to find out the value of p finally. So 16 is equals to 12p. Then p is equals to 16 divided by 12. We will simplify this. 4 table. 4 4s are 4 3s are. So 4 by 3. So therefore the value of p is equals to 4 by 3. So the only thing is, according to the given condition, we need to take the step. The discriminant is there greater than 0 or less than 0 or equal to 0. So we know the rules. When roots are real and equal, a discriminant is exactly equal to 0. So roots are real and not equal means you can take d is greater than 0. If it is so we already learned properties. So according to most of the questions, the last roots are real and equal. Very few questions only they'll ask about roots are real and some case imaginary. So let us see all the questions. So this is one problem. Now let us see. So apart from this, how the questions will come. It's another example now. Now let us see one more problem. So here is the x square coefficient is 1, but x coefficient is 2 into m minus 1, and constant is m plus 5. So without solving the equation, we need to find the value of p. Okay, sorry, m value. So we need to find out the value of m, for which the roots are real and equal. So roots are real and equal, then we need to find out. So according to the problem, we know the discriminant concept. Okay, here is the given, that is x square plus 2 into m minus 1. So if you multiply 2m minus 2 x plus m plus 5 is equals to 0. So according to the general form here, so if you take ax square plus bx plus c is equal to 0. So where this is the general form of the quadratic equation. Then you can find out a is equals to 1 and b is equals to 2m minus 2 and c is the m plus 5. And because of roots are real and equal, So they mentioned equal also. So discriminant is equal to 0, right? If you apply, then d is equals to b square minus 4ac. That value is equal to 0. So whenever the roots are real and equal, you can take this term. Now just substitute the a, b, c values in this, and we'll simplify to find out the value of m. That's very simple. Only thing is we need to know the given conditions clearly. So here b square, b is 2m minus 2 whole square minus 4ac. So a is 1 and c is m plus 5. That is equals to 0, right? Now just apply the formula. So here if you simplify, a minus b whole square formula, if you apply a square 4m square, 2m whole square is 4m square, plus b square 2 square minus 2ab. So 2 into 2 4 8 8m. Just apply a minus b whole square formula, minus 4 into 1 is 4, you multiply this, so minus 4m and minus 4 into 5 is 20 is equal to 0. Now if you simplify this, 4m square minus 12m minus 16 is equal to 0. Again you are getting another quadratic equation type. Just we can simplify and get two answers. If you take 4 common, m square minus 3m minus 4 is equal to 0. Now this is the quadratic equation. Just take 4 common and 0 by 4 is 0. Now again splitting in the middle term, same like previous exercise how you learn, right? So m square is a minus 4 split in two parts. Okay, 4 ones are 4, but minus 4 we need, so minus 4 into 1. So minus 4m plus 1m, minus 4 is equal to 0. Now take m common, m minus 4 plus 1 common, m minus 4 is equal to 0. Now m minus 4 if you take common, then m plus 1 is equal to 0. Just to separate this by zero product rule, that is m minus 4 is equal to 0 or m plus 1 is equal to 0. From this m is equals to 4, so one of the answer, or m is equals to negative 1 minus 1. Okay, these both are the answers now. So hence required the values of m are 4 and minus 1, right? These are the answers. So only the thing is main we need to see the given condition, whether roots are real or equal or not equal. So next problem I will show when the roots are only real, they are not mentioned equal, then how to solve. So that problem also let us see now. Now let us see the another type of question in this. So without solving the following equation, just find the value of k for which the roots are real. So they mentioned only the roots are real here. So there are three cases. They will mention sometimes roots are real and equal. That means discriminant is equal to 0. When they mention only roots are real, we'll take the discriminant is greater than or equal to 0. Okay. And if it is they mention only the distinct real, we'll take the discriminant is only greater than 0. So three cases. Now this is the second case. We have to take discriminant is greater than 0. So before solving, so if you take the general form, so the given quadratic equation, that is 3x square minus 2x plus k is equal to 0, right? So here if you take the general form, ax square plus bx plus c is equal to 0, then from where a is equals to 3, b is equals to minus 2 and c is equals to k. So the discriminant, so d is equals to b square minus 4ac. So that value if you check, 3 square minus 4 into, okay, b is minus 2. So minus 2 square minus 4ac. A is 3 and c is k. This value is 4 minus 12k. But they mentioned here roots are only real. So roots are real means then account the condition d is greater than or equal to 0. Right? This is important. According to the condition, you take the step. So whenever they mention only roots are real, just to take discriminant is greater than or equal to 0. So from this 4 minus 12k is greater than or equal to 0. Now this is an equation we can solve from this. So we can solve simply. Then 4 is greater than or equals to 12k. So minus 12k, take right side, plus 12k. If this 4 is greater than or equal to 12k, then 12k is less than or equals to 4, right? Then k is less than or equals to 4 by 12. Let's simplify. So if we cancel 1's 3. So k is less than or equals to 1 by 3. Now the k value is less than or equal to 1 by 3. So therefore the required set, that is equals to, here k belongs to real numbers, all the real numbers, and that k is less than or equals to 1 by 3. Now this is the solution set for this. So that is important. Solving is same, but we need to take the step. So what step we are taking according to the condition, that is important. Here discriminant is greater than or equal to 0, because they mentioned roots are only real. If they mention roots are real and equal, same like previous example, you take discriminant is equal to 0. Okay, only roots are real, discriminant is greater than or equal to 0, both. So next problem I will show if there are distinct real roots. So then how to take that step. So let me show one more example which will take only, not only real, the distinct real roots. Now let us see the problem based on the natural numbers or nature of the roots of the quadratic equation. In this case, to solve the problem, so without solving the following equation, to find out the value of k when the roots are distinct real. So this is important. So we are seeing the nature of the roots. So whenever they mention roots are distinct real, we need to take discriminant is only greater than 0. Okay, they mention distinct, so different. That means it's not equal to 0. There should be two answers. That means only discriminant must be greater than 0. Okay, from the solution. So if you take the given equation, kx square, we need to find out the k value, plus 2x plus 1 is equal to 0. So according to the general form of the quadratic equation, that is ax square plus bx plus c is equal to 0. So where we can write the value of a, b, c. So a is the x square coefficient, that is k, and b is the x coefficient is 2, and constant is c, that is 1, right? And the main important thing is they mention distinct real. So that's why we need to take these. First we'll find out the discriminant, b square minus 4ac value. So that is b square. So 2 square minus 4 into a is the k and c is 1. Right? That is 4 minus 4k. But according to the distinct real, so we need to take now d is greater than 0. Okay, only roots are real. They mention we'll take d is greater than or equal to 0. If they mention roots are real and equal, just to mention d is equal to 0. If they mention only distinct real roots, just take d is greater than 0. That's important. So 4 minus 4k is greater than 0 because of roots are distinct real. Now let us simplify this symbol. That is 4 greater than 4k. When 4 is greater than 4k, then 4k is less than 4, right? Then k is less than 4 divided by 4. Just simplification you can do. Then k is less than 1 because 4 get cancelled. Now based on this we can write the therefore required solution set. So required set is here. Now k is belongs to the real numbers, all the numbers, but k condition is less than 1, right? Okay. So in this problem also the main thing is whenever the according to the mention, so they mention distinct real, so we should take this step discriminant is greater than 0 and solve. After finding the discriminant is same, but according to the conditions which they mentioned, we should take this step. Only three conditions: whether real, equal, and only real and distinct real. So when they mention the distinct real, you take the discriminant is greater than 0. Okay. Now these are the three types sum solved is solved. Now let me show other two more problems which are just to show that, they're asking show that has no real. So some show that questions and proving type questions I'll explain now. Okay, so now when we observe the problems, so which are based on the nature of the roots, let us see this type of question now. Show that the equation is 2 of a square plus b square x square plus 2 into a plus bx plus 1 has no real roots when a is not equal to b. So the question is the condition there is no real roots. So if there is no real roots, then the discriminant that should be less than 0. So if you prove discriminant is less than 0, then there is no real roots, we can confirm. Okay, let me start the problem. So instead of showing directly, instead of proving, we only said it has no real roots. So instead of finding the discriminant here. So from the given question, okay, so the given equation is, here is 2 of a square plus b square into x square. So this is completely x square coefficient, 2 of a square plus b square plus and 2 of a plus b x. This is completely x coefficient plus 1 is equal to 0. Now there is a constant is 1. So let us take a, b, c. So already small a, small b's are there. Then capital A. Let us take the general form is capital A x square plus capital B x plus c type. Okay. Now 2 of a square plus b square. B is x coefficient. 2 of a plus b and constant is c. So with this, when general form is like ax square plus bx plus c is equal to 0. So if we take this as general form, now abc is this, right? Now we need to prove the discriminant is less than 0. We should prove that is. Then you can confirm that there is no real roots. So therefore, if you take the discriminant, the d is equals to, actually now b square minus 4ac. So I'm taking calculators here. So instead of getting confused with small abc. Now this value we need to prove first less than 0. Now b square. So b is a 2 of a plus b. For this whole square minus 4ac. So a is 2 of a square plus b square into c. So c is 1. Right. Now let us simplify this. Then we can prove this value is less than 0. Now let us take the simplification into it. So each and everything you can simplify. Now 4 of a plus b whole square. If you take 2 square is 4. Now this is a plus b whole square. Right? Minus here 4 into 2. 8. 8 of a square plus b square. Let us simplify this now with the fourth table. A plus b whole square formula apply. That is a square plus b square plus 2ab. Right? Minus this is 8a square minus 8b square if you multiply with 8. 4 you multiply 4a square plus 4b square plus 8ab minus 8a square minus 8b square. Now take the simplification this, that is minus 4a square minus 8a square, that is minus 4a square, and 4b square minus 8b square is minus 4b square and plus 8ab. From this take minus 4 common. If you take minus 4 common, any formula can come inside. See, a square plus b square. Minus 4 is common. From plus 8ab, if you take minus 4 common, then minus 2ab. If you note this is a square plus b square minus 2ab formula is a minus b whole square. Right? Now observe this. So this value. Anyhow, a minus b, if it is negative or positive, because of whole square, this total is positive. Now positive into negative 4. So automatically come the negative value. That means this is less than 0. So therefore, because this value is always negative, right? Whole square. So this is positive. This completely. But positive into negative is again negative get. Now according to this, we can conclude that. So discriminant, that is b square minus 4ac, we got less than 0. Then when a is not equals to b, a is not equal to b, given condition already. If it is a equal to b, then this is 0, this also everything will be 0, right? Therefore has no real roots. We can conclude that there is no any real roots for this. So we only prove that is the less than 0. So any problem is given straight away you can solve, otherwise it has to show that anything you can take this discriminant and prove that according to the given. If they ask no real roots, we should prove that is a less than 0. We prove this, right? Now not only this, when you have to give the two equations, so instead of one, if they give two equations, how to compare and finding the roots. I'll show one example, one more problem now. Okay, let me show one last problem from this topic. The problems based on nature of the roots. Now, when the to find some value, so find the positive value of k, which the equations x square plus kx plus 64 is equal to 0 and x square minus 8x plus k is equal to 0 will have real roots. So when these both have real roots, so what is the positive value of k? They asked. So now these both values will find out the discriminant and we can find out the value, right? So for this, so the given equations are, both are given. Let's take these two equations, x square plus kx plus 64 is equal to 0, one equation, and x square minus 8x plus k is equal to 0. So when you compare this both, let's take two separately, find out the discriminant for both cases. So in this case, d is equals to b square minus 4ac. Okay, whenever they say real roots, that means discriminant is greater than or equal to 0. So roots are real, so greater than or equal to 0 is discriminant. Now this is the b square minus 4ac. Just to find out b square. So here is x, if you observe the terms, just to take the values, so simple. Here is a is equals to 1, b is equals to k, and c is equal to 64. Okay, x square coefficient, x coefficient, and constant. Here also a is equals to 1 and b is equals to minus 8. In the place of c, k is substitute. Now let us find out these values. B square, so k square minus 4 into 1 into 64. Right? This value is greater than or equal to 0. And here also same. So discriminant, that is b square minus 4ac. So that value is minus 8 whole square minus 4 into a into c. C is k. This is also greater than or equal to 0 because they mention real roots, the both. If it is real roots, just directly take greater than or equal to 0. If equal means equal to take, roots are equal. So we know the three conditions. These two will simplify first. So k square minus 64 into 4, that is 256, greater than or equal to 0, and k square is greater than or equal to 256. Simplify separately, right? And k is, if you apply square root on both sides, this you can write 16 square, right? Therefore k is greater than or equals to 60. It will be 1, and this one will solve. Minus 8 whole square is a 64. This minus 4k greater than or equal to 0. So minus 4k take that side. So 64 is greater than or equals to 4k. That means 4k is less than or equal to 64. Okay, 64 is greater than 4k, so 4k is less than 64. From this, k is less than or equals to 64 by 4. That is also 16. Just to cancel this. So k is less than K is less than or equal to 16. When you compare this both, K is greater than or equal to 16 and K is less than or equal to 16. But according to the question, K is a positive. So that from 1 and 2, the both conditions is satisfies, that is K is equals to 16. Okay, K is greater than or equal to 16 and K is less than or equal to 16. So compared to both, the common value is 16, which is the positive, right? Hence both of the given equations will have the real roots when only K is equal to 16. Both equations together will be real roots when K is equal to 16. Right? Just only the conditions you observe according to the problem. Whenever the roots are real, roots are equal, or roots distinct. So based on the conditions, these are the problems I explained. Now this is the information from this chapter, not only this chapter. All other chapters, as I said starting, you just to go to the website and there is a links provided in description below. You can find out all the information which is available there. And don't forget to subscribe the channel because we'll upload only the videos which are related to education. So according to requirement, you can go through it.